Logarithmic equation. We can use the laws of logs to write equations in different forms, and this will be particularly useful to solve powers, especially exponents. So that's what we're going to do here. We want to use the laws of logs to write these in log form. What all that means is we're going to take the log of both sides. So we're going to take the log of this side and take the log of this side. So it's going to look like this for a. Log of y equals log of a squared b. So we wrote it in log form. Now just to practice, let's expand this out. So remember, the way you expand logs is multiplication means addition. So just like this. And then any power has to be moved to the front. We want to fully expand it all the way. So 2 log a plus log b. That's what log y equals. So like that. We do the same thing on this one. So we're going to take the log of both sides. So it'll look like this. Log of p. That's a log. That's just getting worse. Equals log of 20 over square root of n. Right, now minus means divide, and don't forget square root of n is essentially saying n to the 1/2 power. Now, so I'm just going to do that all in one step. So log of 20 minus, because what divide means, and logs, log of n to the 1/2, and then the last thing, we're going to move that power to the front. It becomes log 20 minus 1/2 log n. So there we go. So we can take the log of both sides and then use log rules like we know how to do. This one we want to write without logs. So what that means is you want to have a log on each side. So once you have a log on each side, you could just drop the logs. So we have to combine these sides first. So we're going to combine it. Now, first thing I do when I want to combine it is actually move the power to the front. So we're going to have it like this. And now, these are both a log. There's a plus sign. Plus means multiplication. We're going to combine it, and we're going to get this is saying log of bc squared. Log of a equals log of bc squared. Now there's a log on both sides. Anytime it happens, they can just cancel out. Technically, what's going on here is that there's a log base 10. So you're taking the 10 power to both sides to cancel it out. But the general rule is there's a log on both sides, and there's only there's one log on each side. That's the only thing you have. Then they just kind of cancel each other out, and you just get a equals bc. So we'll do that here with the next two. So now again, so here's a perfect example where I can't just cancel the log because there's extra stuff here. I have to make it all the same thing. They have to make them all log. We have to use our trick again, right? How to make this a log? You do log base 2 of 2. That way I can combine these. And the first thing I do is move these powers to the front. So I get log base 2 of a minus, a cubed, sorry, log base 2 of 2 squared, which is 4. Now I can combine these. So notice that 3 came to power, and that 2 became a power. 2 squared is 4. Minus means divide, so log base 2 of a cubed over 4, log base 2 of m. And now there's only a log on both sides, so we're going to cancel these out. Basically, we're going to take the base 2 power to both sides, and we get this. So there we go. And the same thing if I was doing this one, just to show you one more practice. If I was doing this one right here, I have to use the trick. Now again, these are natural logs, same rules apply though. So I don't have to make this a 1, so I do natural log of e, because that's a 1. Then I'll move this power to the top, and move this power to the top. It's a -1 if you don't see it. Right, it's a negative, but you can always put a 1 in front. So it's like that. It's hard to see. Anyway, natural log of f equals natural log of p to the -1 plus natural log of e squared. Plus means multiply, so natural log of f equals p to the -1 times e squared. Oops. Forgot the natural log. And now, essentially we're taking the e to both sides, but these cancel out, and you get f equals p to the -1 e squared, also known as e squared over p. Like that. Now we can use that exact same principle to solve some logs. So that's what's going to happen here. Now on a solid log, we can't just cancel out the logs. We have to have, again, a single log on both sides. If we have that, then we can just cancel the logs. So for now, we got to combine. Step 1 is combine. And then we're going to cancel. And then we're going to solve. So I got to combine this first. Minus means divide, so I get log 5x equals log 8 over 6 minus x. Right? I mean, subtraction means divide, so this goes on the bottom, this goes on top. So we combined it. It's super important. And now, basically taking the 5 to both sides, but these cancel out, and you get x equals a over 6 minus x. So now all you have to do is solve. Now it's just a math problem. I'll probably cross multiply, and I get x 6 minus x equals 8x. Distribute 6x minus x squared equals 8x. Set equal to 0. Now I don't like having my negatives, my x squared is negative, so I'll move everything to this side. I add x squared to both sides and subtract 6x from both sides. So 6. And I get 0 equals x squared plus 2x. Right, so 8 minus 6 is 2, and then x squared is on this side. Now I'm going to factor out, they both have an x, so I'm just going to factor out an x. And then we're going to split and solve. X equals 0, x plus 2 equals 0, so x equals 0 and negative 2. So that's that one. Next one over here. So again, same idea, but now we have to use a trick again. How do I combine this if there's a 1? Look at the base. We're going to make this log 20 of 20. Log base 20 of 20. So let me rewrite so we can see it first. So this looks like this. Like that, right? And now I combine it because they have the same log. So you combine this, which means plus means multiply. So I get log base 20 of 200. Now these cancel out because they're both log 20. And x equals 200. And that's the lesson.